Motion extraction tutorial for Unity Engine, episode 2, let's go. If you haven't seen episode 1, the link will be in the description, you should go watch that because without it, this one will not make much sense. What you see right now on the screen is the version that I implemented before starting the series, and that's what we're trying to achieve with the tutorials. Now, going back to the actual version that we are working on. So this is the result that we achieved by the end of the first episode of the tutorial series, and as you can see, it is a gray base color with highlighted motion. And it runs on CPU, so it's not performant at all, and that's one of the things that we will be addressing today. Today we'll be doing two things. The first one is writing a shader, and the other thing that we'll be doing is a custom delay. Now let's quickly recap what we have right now, what the current implementation is. We right now grab a frame from the camera, put it into a render texture. On CPU in a C# script, we invert the colors and adjust the transparency, do a 1 frame delay and output the result to the UI on top of the current frame. And then the UI is obviously shown on the screen. Well, that's what the implementation is. There it is in the code. We grab the render texture contents, we invert colors and apply transparency, and then we delay the texture, and next frame we apply it to a raw image that is set up on the UI. And underneath that raw image is the current frame. This is the current frame, and on top of it we overlay the render texture, or the processed delayed frame. So that's what we have, and that's what we are working with. And in this episode, by writing a shader, we'll be moving this part, invert and transparency, from CPU to GPU. And the updated flow of our effect will look something like this. So we once again grab a frame, put it into a render texture, then we, with a 1 frame delay on CPU, put this render texture's contents into another render texture, and then those two render textures go into a shader. So on GPU we do the calculations, we invert the colors and set the transparency, and this is what goes to your screen. This way we are moving the heavy calculations to GPU and optimizing the effect. So in our script, the first thing that I'm gonna do is I'm gonna remove this because we don't need this anymore. I'm gonna actually separate this into a method, and we will call it capture frame. So we are capturing the current frame, and then we need to delay it, and that's really it on the code side. On the C# side, that's all we want to do. We can go ahead and remove the invert pixels method. We will not use it anymore. We will need a second render texture. We'll call it delayed render texture. And what we want to do now is, I think we need to copy the data from our delayed texture to the delayed render texture. And I think this should be it on the C# side for now. Now let's also duplicate our render texture and call it delayed render texture. It should be the same resolution as the main one, and let's not forget to also assign it, of course. And let's also create a shader. So right click, create shader, unlead shader, and let's call it a motion extraction shader. Alright, now let's open it. Now let's do some shader programming. So I'm gonna duplicate the main texture. I'm gonna rename it, one of them into the current texture or current text, and the other one will be the delayed one. So we now have two textures, and let's also do the same thing here. Current text and the other one into the delayed text. And we can actually remove the float for main text st, and here, instead of doing the transform text, let's just do the v.uv. So we don't need the st variable anymore. Now here is where the magic happens. So what we want to do is we want to have the current color and the fixed for delayed color. And now what we do is we can actually, I think we can do it like this. We can subtract the delayed textures color from 1, and then we do fixed for color is current color plus delayed color divided by 2. And I think this should actually be it. I don't think we need the fog here, so let's go ahead and get rid of that. Also don't need this, and we don't need this, because we don't need fog on our output of the shader. Now let's check if it actually works. So what we can do is, yes, save the shader. What we can do is we can create a material. There it is. And we assign both render textures, 1 and 2. Now what we can do is we can create a UI image, stretch it, we can remove the old ones. Actually, let's keep this one. And I think we can just assign the material. Yep, there it is. Except, alright, I really don't feel like figuring out why this is happening, so let's just have the main text, and we just won't do anything. And now I think, yeah, we don't have any errors. Alright, so now I think when we launch it, everything should work, but let's see. Okay, let's see what's happening. So I'm gonna, okay, so it's not working. Let's think why. The delayed render texture is white. Something is not right in our C# script. You know what we didn't do? We didn't apply texture 2D. So that's why applying a texture is important, because otherwise nothing will be in the texture. Nothing will be applied. Now let's see. There we are. That's much better. So as you can see, we have recreated the effect. So it's the same effect that we had after the first episode, but now it's done on GPU. This means we can increase the resolution, so let's go ahead and do that. Let's multiply it by 4. So it's 960 by 540 resolution. Alright, and here let's do resolution X, Y, and int, copy this and put it here as well. Okay, now let's check it out. Should look much better. Okay, so as you can see, the resolution is much higher and the FPS is still pretty good. Yeah, much better. Now let's go to the second part of the tutorial, which is a custom delay. Right now we have a 1 frame delay that is done on CPU. Let's replace it with a custom number of frames of delay by just cycling through a number of frames. This should be pretty easy to do. So instead of having just a single delay texture, let's do public int frames of delay, and let's do an array of textures 2D. Let's call it textures. Now start, let's do textures frames of delay. And now in a for loop, let's just create all the textures equals, and let's just steal this here because we won't need it in this place. We'll need it here and here. Alright, so what we're doing here is we're creating all the textures and setting the filter mode to point. Let's actually also apply them. So now we have an array of textures and they're all empty. And let's also introduce a integer frame index. So this will be initialized with a 0 here, and here at the end of update we increment it just like that. We can remove this. We can actually remove that because we don't need this. The capture frame does not need to return anything anymore, so it can be like this. And here we can do textures current frame index, and that is good. So the capture frame now just captures the contents of the source render texture into the current frame inside of the textures array. And we can also update this. So instead of the delayed texture, it should be textures current frame index, because we incremented it in the previous frame. This will now be, surprisingly, the delayed frame, and it should all be fine. And we don't need the null check because we initialized all the frames on start. And with that, I think we are good. Let's check if it compiles. Yep. And now let's see frames of delay. Let's say 10 frames of delay. And also what we can do is we can remove the raw image, we no longer need it. And yep, as we can see, the delay is now much longer, and that's exactly what we wanted to achieve. Except for now, let's just keep it small. Let's do like 3 frames of delay, and there we are. So that's it for this episode. As you can see, the results that we achieved are quite good. Both the resolution and the frame rate are much higher. There is a custom delay in the number of frames, and generally I think the effect is shaping up pretty well. Now in the next episode, what we are going to do is we're going to introduce colors and customization. Hope you are looking forward to that. If you have any thoughts or suggestions for what to do with this effect, please leave them in the comments below. And for today we are done. Thank you for watching and have a great day.